Deeksha Karnataka YouTube channel, and in the Zero to Hero series today I am going to discuss a very important chapter, moving charges and magnetism. Now moving charges and magnetism, generally students, even though it's a slightly easy chapter, students generally ignore it, and in the exam hall they face difficulty while answering the questions. Now why it is so, we are going to explain that everything. This chapter is not only important for your KCET exam, this is a very important chapter for your PU2 exam as well. So let's see the weightage of the chapter. So here are the important topics: Lorentz force, motion of a charge in a magnetic field, force on a straight current carrying conductor, ammeter and voltmeter conversion, Ampere's law, magnetic field on the axis of a circular current carrying loop, force between two parallel currents carrying wire, torque on a rectangular current loop. These are all the important topics from this chapter. And if you see the weightage of PUC, total 1 mark question is 1, 2 mark question is 1, 3 mark question is 1, 5 mark question is 1. So total marks that is coming from this chapter is 11, which is very high weightage in terms of PUC, okay, because the exam is only about 70 marks. So if you study this chapter, 11 marks you can put into your pocket. Right now, if you see the KCET weightage, in 2025 4 questions directly came from this chapter. In 24 5, 23 also 5, 22 5, 21 5, 25. So on an average we can expect 5 question, minimum of 4 question and up to 5 question we can expect from this chapter. Now because there is no numerical question coming from this chapter in PUC, students only do not practice too much numerical from this chapter and they struggle in the KCET exam. So you have to, even though long form 5 marker numerical questions are not coming from this chapter, you have to practice some mathematical problems, some level of at least KCET level PYQs and KCET level questions, so that you are ready in case some mathematical based question coming from this chapter. We will see throughout this lecture and solve some questions. And if you see the PUC analysis of this chapter, you will see that Lorentz force came twice, motion of a charge in a magnetic field came twice, force on a current carrying conductor came only once in 2020. Ammeter and voltmeter conversion is one of the most important topic from this chapter, and it came 4 times in last 5 years. Ampere's law came 3 times. Magnetic field due to a circular current carrying loop came 2 times. The derivation, force between two parallel wires, came 3 times. So every alternate year either this derivation or the other one derivation comes. So this year we can expect magnetic field due to a circular current carrying loop most probably will come. Torque on a current carrying loop, this also came 2 times. Okay, so this is all the important topics, and this is how many times they have came in your PUC exam in last 5 years. Right now let's start with this chapter. First we will start with basic introduction. So basic introduction means in your class 10th, last chapter was magnetic effect of electric current. Maybe some of you have studied it properly, some of you have not studied that part properly. So let me explain that ancient India history is saying hi ancient India history. So we are here to make history. So I hope you are ready for that. So let's see. Moving charges or currents produce a magnetic field in a surrounding space. Okay, so whenever there is a moving charge or a current, it produces a magnetic field in the surrounding space. Remember that moving charge, moving electron, moving electric current, they do not produce any electric field, they only produce magnetic field. They only produce magnetic field, but electric field is not produced by a moving charge. Moving charge only produce electric field, moving charge, single moving charge produces electric field as well. But if you are considering electric current only produces magnetic field. Electric current does not produce any electric field. Okay, so remember this, only charge, okay, it will produce electric field, as well as magnetic field. But if you are considering a current, it only produces magnetic field. So based on this, you might see an objective MCQ question in your PUC or in your KCET exam. So you should be a little bit of careful about it, that if there is a current involved, only magnetic field. If it is a single moving charge, it will produce electric and magnetic field, and they will be phase locked. Basically that will produce electromagnetic wave. Okay, SI unit of magnetic field is Tesla. Okay, not the person, not the car manufacturing Tesla, it is Nikola Tesla, some great physicist who discovered a lot of currents effect, and also did some research on how can current be transferred, right? And dimension of magnetic field is given by m t to the power of -2 a to the power of -1. M is mass, T is time, A is current. Now if you see, there are two currents I have shown in this diagram. Here current is coming out of the page. Dot means out of the page, cross means into the page. Okay, dot and cross. Dot means out of the page and cross means into the page. So this is out of the page. And this is into the page. Now how can you remember? Sometimes it can be tricky. So remember, cross means it's like a dartboard where you are practicing throwing by throwing some needle towards it. Okay, so the cross represents a dartboard where you are throwing needle. So this is your target. That means this is into the page. Okay, whereas dot means it is a wire which is coming out, and that's why it is out of the page. So current, if a current carrying wire carrying current in the out of the page direction, then the magnetic field lines will be like this. Okay, so this is how a small magnetic needle will orient itself if a current carrying wire is kept like this. Similarly, if a current carrying wire is kept in this way, so current is being carried into the page, then the magnetic needle will still orient itself, but the polarity will be opposite. So basically, what is the shape of the magnetic field in this case? The shape of the magnetic field, if you join them, it will be a circular magnetic field. Okay, the shape of the magnetic field will be circular in nature. Okay, so they are all concentric circular magnetic field. You have done one experiment in your class 10th. Some of you have done it in the lab. Some of you have just seen the demonstration where there is a cardboard, you have a straight wire carrying current, then you have thrown some iron filing onto the cardboard, and then you tap it, and the iron filing magically orient into the circular way, right? Now now whenever there is a current carrying current or a charge which is in motion, okay, it produces electric and magnetic field. Now reverse the situation. How you can reverse the situation? Suppose now you have a moving charge and you have kept it inside a magnetic as well as an electric field. So electric and magnetic field both exist together, and you want to know what is the effect if I allow a moving charge to pass through both electric and magnetic fields. Suppose we have an electric field and we also have a magnetic field. They are oriented and random direction, it not necessarily to be any particular fixed direction, and you are also allowing a charge particle to move through it. Okay, so if you allow a charge particle to move through electric as well as magnetic field, then it experiences a force, and that force is called Lorentz force. The name is Lorentz force. When a charge moves through a space having both magnetic and electric field, it experiences a force. Okay, now force due to electric field. Suppose only electric field is there, a charge is moving. So what is the force on this charge? The force on this charge is given by, electric force is given by Q into E. We know that if a charge particle is kept in an electric field, it experiences a force Q into E. Whether it's static, whether it's motion, does not matter. The force acting on a charge due to electric field will always be Q into E. Okay, now based on the sign of the charge, it can be towards the electric field or away from the electric field. It is independent of the motion. Okay, the force acting on a charge due to electric field does not depend on its motion, it only depends on the charge, value of the charge and magnitude of the charge. But the force due to a magnetic field does depend on the motion. Okay, so this was our magnetic field. So force due to magnetic field does depend on the motion. Okay, based on the direction of motion, the force due to magnetic field is given by Q into V cross B. Okay, V is the velocity vector and B is the magnetic field. Okay, based on the direction and direction of magnetic field as well as the direction of velocity. Okay, the field, the force acting due to magnetic field does change on the depending upon the angle and direction of the velocity. Okay, so total force on the moving charge is given by, so total force means two different forces, you have to add them. Now here when you are adding, you have to add them vectorially, very important, you have to add them vectorially. Lorentz force, sometimes be asked what is Lorentz force, write its expression and explain the terms. So when you are writing the expression for Lorentz force, it has to be in vector form because the direction of electric field vector E and V cross B can be well different, so it has to be a vector addition, not a scalar addition. You cannot simply add them value wise, you have to add them vector direction wise. Okay, this force is called Lorentz force. This force is called Lorentz force. What else? For most of the numericals, we will be using only the magnetic force, which is given by QVB sin theta. So if you are solving a numerical question, most of the cases electric field will be given as 0, or they will not even mention electric field, they will only mention the charged particle is moving with so and so velocity in a magnetic field with some angle, then what is the force acting on it. So in that case, the force acting on a moving charge in a magnetic field is only the magnetic force component, because there was a cross product. Cross product means it has to be, if you try to find the magnitude, it will be sin theta. Okay, so if this was the magnetic field and this was the velocity, so the angle between the velocity and magnetic field is given by theta, then V cross B, the magnitude of V cross B will be VB sin theta, right? We all know, we have learned it in our PU1 motion in 2D, where we have done cross product, and cross product basically means sin theta, dot product means cos theta, right? So here the force, many cases in most of the competitive exam cases questions, whenever you are solving, it will be QVB sin theta, right? Let's move on and see one question. This question came in KCET 2021, but this question might be coming in your PUC exam as well in a for MCQ part. Okay, a strong magnetic field is applied on a stationary electron. Then the electron moves in the direction of the field, moves in an opposite direction of the field, remains stationary, starts spinning. So what is the case? So a strong magnetic field is applied on a stationary charge. So charge is stationary. Stationary means it is not moving. So not moving means its velocity is 0. If you have any doubt, any question, don't forget to ask me in the chat. I am here to answer all of your questions. Now, what will be the answer for this question? Anyone wants to answer? Feel free to answer. Otherwise, I will answer it myself. Okay, so a static charge or a stationary charge means it is not moving. Okay, the motion of the charge is not there. So if the charge is not moving, then when you apply an external magnetic field to that, what will happen is that what is the force? Magnetic force. Magnetic force is QVB sin theta. Okay, now Q is not 0, but velocity is 0 because the charge is not moving. So if the charge is not moving, no matter how strong the magnetic field is, the force acting on it will be 0. Okay, so force acting on it is 0 means the charge will remain stationary. First law of motion. Okay, if no force acts on an object, the charge or the object will remain in its state of rest or state of motion. So in this case, a force is 0, object is at rest, so it will still remain stationary. The charge will still remain stationary. So correct answer is option C. Now next, let us continue with the discussion of Lorentz force. Force on a negative charge is opposite to that on the positive charge. So the formula that we have written here, force equals to Q E plus V cross B. If the charge is positive, the force will be suppose in this direction for positive charge. Then for negative charge, the force will be in the opposite direction. Okay, so whenever we are applying this formula, generally we are assuming the charge is positive. So remember that in case they ask you what will be the direction of the force and they give you a negative charge, then after calculating the direction, you have to make sure it will be in the opposite direction of that, because the charge given is negative. Now, how to find the direction for V cross B? Let me explain that as well. Okay, so how to find the direction of V cross B? Suppose this is the direction of V, this is the direction of B. Okay, so how to find the direction of the resultant vector? Okay, so the resultant vector is basically V cross B. V first, B second. So remember that whenever you are finding the direction due to the cross product, how to find the direction? You have to use right hand rule. Right hand rule. So you have to align your fingers in the direction of the first vector. Okay, you have to align your fingers in the direction of the first vector. Then you have to rotate your fingers towards the second vector. Then your thumb will give the direction of the resultant vector. Hi Dhanush. C, electron remains stationary. Yes, Saida. Yes, you are correct. Dhanush is also correct. So when you are applying the cross product law, okay, to find the direction of two vectors cross product, then the direction should be first vector cross second vector and your thumb will give the direction. Okay, remember this will be very, very helpful, especially in related to direction related question. Okay, a charge is moving in northeast direction, a force is magnetic field is in the downward direction. What will be the direction of force? So these kind of questions are common across, maybe not from this chapter but from the next chapter where you are studying magnetic field. From that chapter also you might face one or two questions such as this. So cross product means first vector cross second vector, thumb gives the direction. Okay, thumb gives the direction. Now force on a negative charge is opposite to that of the positive charge. So that V cross B that you are doing, that is valid for positive charge. So if the charge is negative, after doing V cross B, you have to reverse your finger and the opposite, exact opposite direction will be the direction of the force. So this is very, very, very important, especially for KCET preparation. Okay, this concept is very, very important for KCET preparation. The vector product makes the force due to magnetic field vanish or become zero if velocity and magnetic field are parallel or anti-parallel. Okay, so we know that magnetic component of the force was given by QVB sin theta. So if the velocity and magnetic field, they are parallel or anti-parallel, anti-parallel means reverse. If they are parallel or anti-parallel, sin theta, in this case theta equals to 0 and in this case theta equals to 180 degree. So theta 0 and 180 degree, both cases the sin theta is 0, so the force will also be 0. So if something is moving parallel to the magnetic field or anti-parallel to the magnetic field, the magnetic force should be 0. What else? The magnetic force is 0 if the magnetic force is 0 if charge is not moving as V, magnitude of V is 0. So magnetic force is also 0 if the charge is stationary, the last question that we have answered. only a moving charge feels the magnetic force. Very important, only a moving charge feels the magnetic force. Stationary charges is not feeling any force. So if you are feeling a force, okay, I have so much to study, I have so much concept to remember, because you are studying, okay, that means you are studying, you are in a correct track. Okay, so if you are static, you are not doing anything, okay, then you will not feel any force, because you are stationary, you don't care, okay, whatever happen will happen. But if you study, then you will remember, okay, I have to finish this chapter, I have to finish that chapter, because you have started studying, then only you will feel some force. Okay, if you are not studying, you will not feel any force. Now, motion of a charged particle in magnetic field, very important, very important concept from this chapter. Suppose we have a magnetic field, cross represents into the paper, cross represents into the paper, dot represents out of the paper. So magnetic field is into the page of the paper. Okay, a charge which is rotating in the moving in a direction perpendicular to the magnetic field. So if the charge is moving perpendicular to the magnetic field, there will be a force acting on this charge towards this direction, and this will try to bend it in this direction. So the charge will slowly starts moving like this, and because this force is perpendicular to all three of them, okay, the charged particle will start moving in a circular motion. Okay, each and every point, if you apply V cross B, okay, V cross B, okay, you will find the force is in the opposite direction. Okay, so V cross B, you will find the force in the opposite direction. Okay, so V is in this direction, B is in this direction, and this is a negative charge shown over here. So negative charge means even though V cross B is giving you a direction up, because it's a negative charge, the force is in the opposite direction. So both concepts are covered over here. Now, a charge moving in an uniform magnetic field, the force is QVB sin theta. That is fine. Now, if theta is equals to 90 degree, then sin theta becomes 1. Okay, for theta 90 degrees, sin theta is 1. Now, if sin theta is 1, okay, the particle will start moving in a circular motion. The particle will start moving in a circular motion, and this force sin theta is 1. This force will actually provide the required centripetal force for motion. Remember, whenever an object is moving in a circular motion, whenever, no matter what, okay, if an object is moving in a circular path, some force has to provide the required centripetal force. Okay, if hi sir, I am Simran. Hi Simran, how are you? Welcome. Okay, so whenever whenever an object is moving in a circular path, there has to be a centripetal force, and that centripetal force has to be provided by some other force. Centripetal force is not a force which comes into effect on its own. Okay, like gravity is there even if there is nothing. If two masses are there, gravitational force is there. If two charges are there, Coulomb force is there. Okay, you don't have to do anything for that. But centripetal force is not like that. If object is moving in circular motion, centripetal force is required, and it has to be provided by something else. For example, if you went to some Wonderla, suppose you visited Wonderla and you want to enter Wonderla, or some amusement park, whatever is nearest to you, or some zoo, okay, you have to pay the ticket, entry fee to enter. Okay, no one is going to pay the entry fee. You have to either you or your parents have to pay the entry fee to enter the garden, right, or the amusement park. So in that case, the centripetal force is the entry fee for the circular motion. Okay, if the entry fee is not paid, circular motion will not possible, the charge will exit, or the motion will not be possible. Okay, so in this case, because it is moving in a circular path, perfect circular path, so that means the magnetic force, the force acting on this charge due to the magnetic field, that will provide the required centripetal force. Now centripetal force's formula is very simple, mv square by r. So this force must provide the required centripetal force. So this is a very basic fundamental level concept. Okay, if you understand this, many of your physics problems, circular motion related problems can be solved. Okay, so the force required for circular motion is centripetal force, and that has to be provided by something. Here the magnetic force is providing the required centripetal force. This force acts as centripetal force and produces a circular motion perpendicular to the magnetic field. Okay, now radius of this circular path can be calculated as mv by qb, angular frequency is given by qb by m, and time taken for one revolution is given by 2 pi by omega. So let's derive all the concepts. Radius of the circular path. How to calculate the radius of the circular path? So radius of the circular path, we have to start from the basic equation, mv square by r equals to qvb. Okay, now we have velocity on both sides, so one of the velocity will be cancelled. Okay, I don't know what wrong were here. So one of the velocities will be cancelled, and if you do the cross multiplication, you will get r equals to mv by qb. Okay, r equals to mv by qb. From here you get mv by r equals to q into b. Okay, or 1 by r equals to qb by mv, or r equals to mv by qb. Clear? So that's how you do this derivation. So this derivation is important in your PUC exam. 3 marker question, even 2 marker or 3 marker question might come from here, but you have to mention where this formula is coming from. You have to mention that when a charged particle is moving in a under a magnetic field perpendicular to magnetic field, the magnetic force is qvb sin theta is 1. So the force is qvb. Because of this, it will start rotating in a circular motion, and the required centripetal force is mv square by r. So this magnetic force must provide the required magnetic field, and then you compare these two. Okay, and from there on it's very simple, the derivation as I have shown. So after doing that, you can box it, and this is your answer. But sometimes instead of asking r, they might ask you find omega as well. So what to do in case they ask you omega? So in that case, what you have to do, you have to find the velocity v from this same equation. From the same equation, after reaching over here, you calculate v from this equation. So if you calculate v equals to qb cross multiply r divided by m. So v equals to qbr divided by m. Okay, now in rotational motion, velocity can be represented by r into omega. Okay, those who have forgotten that concept in your first PU, just refresh your memories. V equals to r into omega. So if you know this, substitute this r omega back to this equation, then r will be cancelled in both sides, and you get omega equals to qb by m. qb by m. Okay, now this is angular frequency. Angular frequency means angular velocity. Okay, angular frequency or angular velocity are same. But what about normal velocity? Normal frequency. So normal frequency is given by omega by 2 pi. Normal frequency is omega by 2 pi. We have used this formula in alternating current chapter as well. Okay, when you are finding the XL, XC, okay, there is a 2 pi coming in the division, because frequency is given by omega by 2 pi. So omega equals to 2 pi f. Either you remember omega is equal to 2 pi f, or you remember frequency is equal to omega by 2 pi. So in some cases you might be given a question where they ask you calculate the frequency, so you should be remembering this formula. So from here we can say that frequency equals to qb by 2 pi m. qb by 2 pi m. The time taken for one revolution is called time period. So the time period is given by 2 pi by omega. Sometimes this frequency is also called cyclotron frequency, but cyclotron is no longer part of the syllabus, so cyclotron frequency is no longer, the term is not used, but this frequency is also called cyclotron frequency. Those who are giving JEE exam, maybe you have heard of it, maybe you have solved some question based on it. Okay, so this is called cyclotron frequency, the same frequency. The time taken for one complete revolution is given by 2 pi by omega, 1 by frequency or 2 pi by omega, so it is 2 pi m by qb, 2 pi m by qb. Okay, this is the time period formula. So all these formulas are important for your KCET exam, and these two derivations are important for your PUC board exam. Now let's move on. Motion of a charge in a magnetic field. Okay, if velocity has a component along B, so suppose magnetic field and velocity, they are not exactly perpendicular, but they have a partially, suppose this is theta, this is V, so there they have a component V sin theta along this direction and V cos theta along the direction of magnetic field. Okay, so if velocity has a component along the direction of V, okay, this will not experience any force. Force will act only in this direction. Okay, so this component will try to make the object rotate in a circular path, whereas this force, this velocity will remain unchanged and it will try to take the object in the forward direction. So we will get a mixture of circular motion and linear motion. This one is responsible for circular motion, and this one is responsible for linear motion. So if the velocity is not exactly perpendicular to magnetic field, then some weird thing happens, and that motion is called helical motion. That motion is called helical motion. So it looks like this. So the velocity is not exactly perpendicular to the magnetic field. Magnetic field is in this direction. Velocity is at some direction which is not perpendicular to B. So what will happen? We can take one perpendicular component, one parallel component. Now this parallel component along this direction, because it's parallel, no force acts along this direction. So this component of velocity will remain unchanged. Okay, so like in your projectile motion, if you remember projectile motion, there is a vertical component, there is a horizontal component. Horizontal component remains unchanged, only vertical component changes. Similarly, the vertical component over here will take the object in a circular motion, and the horizontal component will remain unchanged, it will take it in the forward direction. So circular motion is there, but circle is not fixed, so circle is moving with time. So this motion, this type of motion is called helical motion. One of the common structure that you may have seen is a spring. Okay, so when we are kid, the pen, the tipping pen was very popular. You tip on the back of the pen and the lid comes out, and you write it and then you close it, right? You also have used it. Inside that pen there is something called a spring. The structure of the spring is basically a helix. Okay, and the completed structure is called helix, and the motion is called helical motion. Sir, I'm dropper for NEET and now I shifted to KCET. Is this enough, sir, for KCET 1000, sir? Ullas Yatgir. So Ullas, you should definitely follow our master stroke series. Master stroke series is more appropriate for your KCET preparation. This lecture is also very suitable for KCET preparation as well as board preparation, but because you are a dropper, KCET preparation is more important. So master stroke, we are doing the same chapters again and again, don't worry, and master stroke is more compact, so you should definitely check out our master stroke series. Master stroke series is well balanced and it has produced result last year, and it is going to produce result this year as well. Okay, so if you are very interested in KCET, then master stroke all subjects, not only physics, chemistry, maths as well, all 3 subjects are essential. If you are also wanted to know about biology, because you are a NEET dropper, so you can check our master stroke biology lectures as well. Okay, so master stroke is more complete, where we are going to discuss concepts not as depth. This is more focused towards learning the depth of a concept, where you may have some knowledge gap. So that knowledge gap we are discussing in live, so that if you have any doubt, any questions, that knowledge gap can be covered. Okay, my PCM marks is 270, is not that bad. Okay, you should attempt at least 160 plus in KCET. If you get 160 plus in KCET, you will get a good rank in KCET. Okay, 150, 140 may not be that. You will get around 5K rank. Okay, with 270 and 140 plus marks in KCET, you will get around 5K rank. Okay, 5K to 7K rank. But if you improve that score to 160 in KCET, then definitely you can get a rank below 1K. Okay, generally 290 plus is more better for KCET rank, but still 270 is not that bad. You need to work a little bit better for KCET, so that you can score a good rank. But NEET, anyway, if you are a dropper for NEET announcement is not yet done. Maybe tomorrow or day after tomorrow they will announce the dates for NEET. So don't lose hope. You should also prepare for NEET as well. But KCET, I think, will happen first, then NEET exam will happen in month of May. So you should, right now you should really focus on KCET preparation. Okay, and that's why we started our master stroke for droppers, for current students. Everyone can learn from master stroke. This series is also good. Here we are discussing more basics. So if you lack any depth of concepts, suppose you have studied some concept in the past, but you have only memorized those things, you have not understood them, then definitely you should consider it. You have doubts, ask me, I will help you. Okay, now let's continue. So this motion, this kind of motion is called helical motion, and the structure is called helix, and all of us have seen helix in springs. Solve a question. A particle of specific charge, this is from KCET 24, last year. A particle of specific charge means the ratio of charge by mass is called specific charge. Okay, a particle of specific charge Q by m equals to pi coulomb per kg is projected from the origin towards positive x-axis with the velocity of 10 meter per second in a uniform magnetic field B equals to 2 k cap t. The velocity v of the particle after time t equals to 1 by 12th second. So first of all, so let us understand, let us decode the question first. Here we have a particle which is projected in the x direction. Okay, so the velocity is basically 10 I cap. Velocity of the particle is 10 I cap. I am on, and the magnetic field is given minus 2 k cap. Okay, so only z axis is there, so I am drawing only the z axis. 2 axis you can take any 2 axis, so z axis I am taking, y axis I am ignoring. Why? Because y is not important over here. Okay, we will try to find the whether y axis will come or not, but anyway, so there is a magnetic field which is acting in this direction. Okay, magnetic field is acting in the minus 2k, so minus 2k means minus 2k Tesla, that means it is in the negative z direction. Okay, now what? Now it is said that the velocity of the particle after time t equals to 1 by 12 second. So because time is involved, we have to calculate the time period of motion. Okay, time period of motion is given by 2 pi m by q into b. Okay, time period of the circular motion we have to calculate first. Okay, so based on this we will see whether the particle will move or not. Okay, so time period is given by 2 pi into m by q divided by b. Okay, now q by m is given as pi. So q by m is pi. That means m by q will be 1 by pi. So 2 pi divided by 2 into 1 by pi. So because time period is positive, we are ignoring this negative sign. This negative sign is only to find the direction. Okay, so 2 cancels, pi cancels, and we get the time period to be 1 second. So time period to be 1 second. Okay, now what? Now we have to calculate the velocity. Velocity is a vector quantity. So when you are considering the y axis, okay, this will be the y axis, okay, in the perpendicular direction. So the particle will actually experience as a force which will take it in a circular motion. Okay, the particle will move in a circular motion and it will reach somewhere here. Because velocity and magnetic field are perpendicular, it will reach somewhere here. If you can find this angle theta, you can find the velocity vector. So velocity vector will be given by this velocity v into suppose this is theta, then it will be cos theta I cap plus sin theta j cap. Okay, because now if you consider only x and y axis, z axis is into the page of the paper, okay, then the particle is rotating in a circular motion, okay, because velocity and magnetic field are perpendicular to each other. So if you can find this time period, you have calculated the time period. Now if you can find the theta, then you can even calculate the velocity vector. Magnitude of the velocity should remain constant. Okay, magnitude, it started with 10, so magnitude should also remain 10, but direction has changed, so you need to find the direction basically. Now how to find the angle theta? Okay, that in that case we will use the time period t. So if a particle is rotating in a circular motion, it will rotate by an angle of 360 degree in time capital T. So it will rotate an angle 360 degree in time capital T. Okay, so 360 degree is the angle for one time period rotation. Okay, so here the particle will rotate 360 degree in 1 second. So in 1 second the particle will rotate 360 degrees. In 1 by 12 second, what will be the angle? 360 degrees into 1 by 12. So why we calculated the time period? We need to calculate the angle. And how to calculate the angle? In one time period it completes one complete rotation. That is the definition of time period. So if you know the time period, you can convert 1 by 12 second into another angle. Okay, so it will be 30 degrees. So the angle is 30 degrees. Okay, now we just need to use this formula. Now, so V is 10 cos 30 I cap plus sin 30 j cap. Okay, so cos 30 is root 3 by 2 I cap and sin 30 is half j cap. Okay, so half is common, so it will be 5 root 3 I cap plus j cap. Okay, so 5 root 3 I cap plus j cap, so option C is correct. Okay, hi Ganesh. Okay, not D. Okay, I think C and D both are given here. One of them should have a different option. So if you are saying C or D, both are correct. Okay, C and D both have same option, so any one of them is correct. Okay, so 5 root 3 I plus J. But anyway, you should have seen C first before moving into D, right? Both of them have same option, no difference. Actually, it should be, one of them should be negative anyway. So you should remember how to calculate. So here in this particular problem, this is a KCET 24 question. Even though the question is tricky, not super simple, but you should be able to solve it if you know how to solve it. That's why solving PYQ is very, very, very important. Okay, you should not ignore previous year questions. Okay, now let's move on to the next question. A proton and an alpha particle are moving with the same velocity, enter an uniform magnetic field with their velocities perpendicular to the magnetic field. The ratio of radii of their circular path is. Okay, so proton and alpha particle, they are moving with the same velocity. Okay, so and they are basically entering a magnetic field, same magnetic field obviously. So what will be the ratio of their radii? Okay, so what is the formula for radii? Formula for radii is mv by qb. Okay, mv by qb. Now velocity is same, magnetic field is same, mass and charge are different. Okay, so if you are saying a proton, mass of a proton say mp, and charge of a proton is simply an electron with positive. Okay, so E plus is the charge, I am just writing E. So what is the radius of proton? Radius of proton is mass of proton into its velocity divided by charge into magnetic field B. Okay, so this is the radius of proton. What about alpha particle? Now alpha particle has 2 protons and 2 neutrons. Now proton and neutron are almost twin brothers, so their masses are almost same. Okay, so mass of an alpha particle is equals to 4 times mass of proton. And alpha particle has, what is symbol of alpha particle? This is the symbol of alpha particle. So it has charge equals to twice of E. So charge of an alpha particle is twice of E. Okay, so basically it contains 2 charges of proton, but its mass is 4 times that of proton. So radius of alpha particle is given by 4 mp into V divided by 2 into E into B. So 4 and 2 cancels and we get 2 mp V divided by E into B. So radius of alpha particle is twice that of the proton. So it will be 1:2. Ratio will be 1:2. Rp by R alpha equals to 1/2. So ratio is 1:2. Okay, in ratio based question, make sure you are following the order given in the question. In the question, proton is coming first, next is alpha particle, and in the answer, in the question they have said the ratio of radii of their circular path. There means first is proton, second is alpha particle. I always mention that in ratio based question, make sure you read the question 2 times, make sure the order is correct, because if you mess up the order, you will get 2:1 as your answer. Okay, but 2:1 is not the answer, 1:2 is the answer. Okay, so make sure you are answering it correctly. So whatever order is given in the question, in the same order you have to find the ratio. Yes, Shravan is correct, Dhanush is correct. Gladwin is saying option A. No, option A is incorrect, Gladwin. I am having practical mocks in my college, so I could not attend classes, sir. That's fine, Gladwin. You are one of the regular student. Echo Vibe is saying option D. Echo, option D is not correct. That's why I am saying make sure you are following the order of the question. So if you are following the order of the question, then it will be R proton by R alpha, not R alpha by Rp. So after solving this much, it might seem that 2:1 should be the answer. That's why I always say make sure you are following the order of the question. This is very common mistake, not by you or anyone else. Okay, it is a very common mistake. Even toppers make these mistakes. So that's why ratio based questions you have to double check it. Okay, not once but twice you have to check. Okay, this is the order. Am I doing it correct? yes, then fine. If it is not, okay, let me check once more. This is the order, then this should be the answer. Because in each and every ratio based question, if 1:2 is the answer, they will give you 2:1 as well. Okay, that is very, very common in ratio based question. Now, easy question. The frequency of rotation of a charged particle in a uniform magnetic field is independent of velocity of the particle, charge of the particle, mass of the particle, strength of the magnetic field. Frequency of rotation means F is omega by 2 pi, that is QB by 2 pi m. So frequency is independent of which quantity? Velocity, charge, mass, strength of magnetic field. M by m. Yes, 2m by m is correct, Eco. So your answer is wrong, right? D. So why it is coming to 1:2, by the way? Because proton has less mass, but it also has less charge. Okay, in this case it has more mass but less charge. Okay, charge is only twice, but mass is 4 times. That's why more mass means it requires more radius. Okay, so more radius means it will rotate in a higher radius orbit. So that's why it is 1:2. Proton will rotate in a smaller radius, alpha will rotate in a higher radius. That is how you should remember. Okay, now answer this question. Yes, Gladwin answered correctly, Dhanush also answered correctly. Yes, velocity of the particle. So as you can see, there is no velocity involved over here. So frequency is independent of velocity. Next question. When the charged particles, this is also, these all questions are taken from your question bank and a previous year question paper if has available. When a charged particles move in a combined magnetic and electric field, then the force acting on it is known as, you have to type the answer. You have to type the answer. This is a fill in the blanks type of question. So what is the answer? When a charged particle moves in a combined magnetic and electric field, then the force acting on it is known as. So when you are typing, let me have some water. Yes, Gladwin answered correctly. Yash Parekh also answered correctly. Ume answered C, but there is no option C over here. If you are saying C over here, the C is wrong for question number 4, Umea. I think you said your name is Simran. So Simran, this is not correct because mass is there. Okay, mass is there in the expression for frequency. That means only velocity is missing. So answer is A for question number 4. And for question number 5, it is Lorentz force. Okay, there will be 5 options given. You will get the answer eventually, but this is the easy question, Lorentz force. Now let's move on to next concept, which is Biot-Savart law. Now Biot-Savart law, Biot is spelling, but this T remains silent. Okay, Biot-Savart's law or Biot-Savart law. Okay, so here Biot-Savart is basically 2 persons. They individually figured out the law, and now they are called Biot-Savart's law. Okay, so here we have a current carrying wire. Okay, this is a current carrying wire, and we are trying to find magnetic field at some distance P. Okay, we are trying to find magnetic field at some distance P. Now, how to find the magnetic field at P? For that, we have to take a small length, because obviously the length is not uniform. So length is, you have to take a small length, which we call length element or current element. Okay, current element. So if you take this current element, this is a very small distance. Okay, and due to this element, the magnetic field at this point P can be represented as dB. dB, because we are taking small element, so magnetic field will also be small. If you want to find the total magnetic field, you have to integrate it. Okay, you have to integrate it. And for symmetrical objects, integration is not difficult. If it is object like this, the integration could be tricky. Okay, if you study about mathematics in future, you might know how to take pieces and integrate it. Otherwise, in your class, it is not possible. Anyway, so dl is a small piece, and due to this piece, magnetic field at this position dB depends on 4 things. First of all, dP is proportional to the current that is being carried. Okay, so it is proportional to current I. It is proportional to the length of this element. So how big the element is, depending upon that, the magnetic field will also vary. It is inversely proportional to the square of the distance. So whatever is the distance, it is inversely proportional to square of the distance. And it is also proportional to the sine of the theta. Now what is sine theta? If you take the direction of the current as the direction of dl, then this direction represents dl vector. This direction represents dl vector. Okay, so dl vector and the radius vector, if you take the radius vector and dl vector, the angle between the dl vector and radius vector is theta. And if you take the sine of that, it is also proportional to sine theta. Okay, so that means the combined form of Biot-Savart's law is the magnetic field due to a current element is given by mu naught by 4 pi I dl sine theta, not IPL, I dl. Okay, so I dl sine theta by r square. Now vector form, this can be represented in vector form. So when you are writing in vector form, remember sometimes in PU exam you might be required to find the vector form. I think in KCET exam also it came once, where they ask you what is the correct form of vector form. So it is mu naught I dl cross r, dl cross r divided by r cube, because we are multiplying with r vector, so that means we are multiplying with one magnitude of r higher. That's why it will be dl cross r divided by r cube. It is normally, if r vector is not there, it will be r square, but because we are actually adding r vector means what? R vector means magnitude of r and r cap. Okay, magnitude of r into r cap. So basically what you are doing, you are adding one extra magnitude. So because you are adding one extra magnitude, you have to divide by that same extra magnitude. So that's why it is r cube. Remember this. Okay, so this again came in exam. So here this mu naught by 4 pi is 10 to the power of minus 7 Tesla meter per ampere. Mu naught by 4 pi is 10 to the power of minus 7 Tesla meter per ampere, and mu naught is called permeability. Epsilon naught was permittivity, mu naught is permeability of free space. Its dimension is also important, so try to remember the dimension as well. ml t to the power of minus 2 a to the power of minus 2. You can find the dimension, but not from this equation. I will show you a few future equation where you can even calculate this dimension. From this equation, it is slightly tricky to find the dimension. Okay, permeability of free space is ml t to the power of minus 2 a to the power of minus 2. Okay, so this is Biot-Savart's law. Next is force on a current carrying wire. So far we have discussed force on a moving charge. Okay, now current carrying wire consists of what? Moving charges. So it is not a single charge, but it has lot of moving charges, and the moving charges are basically electrons. So if you take a moving current carrying wire, okay, and if you place it in a magnetic field, this wire will also experience a force. Okay, so whenever you place a magnetic current carrying wire in a magnetic field, this also experiences force. Okay, and that force is given by I into L cross B. I into L cross B, that is BIL sine theta. Okay, BIL sine theta. So because if you remove the cross product, this becomes sin theta magnitude wise. So BIL sin theta is the force acting on a moving current, force acting on a current carrying wire placed in a magnetic field. This is very simple but yet very powerful equation. Okay. Okay, question number 2 you are answering. Okay. Yes. Now, next, magnetic field due to straight conductor. Magnetic field due to a straight conductor. So, if you have a straight current carrying wire and it is an infinite wire, okay, suppose it's a finite. First, let us take the finite wire. So, finite wire, okay, and if you are trying to find magnetic field at this point P. You are trying to find magnetic field at this point P. Okay, in that case, the magnetic field is given by mu naught I by 4 pi r sin theta 1 plus sin theta 2. So, what is sin theta 1? Sin theta 1 is this angle is sin theta 1, this angle is sin theta 2. Sometimes this angle will be given. Okay, in that case, instead of sin theta 1, sin theta 2, it will be cos theta 1, cos theta 2. Okay, if this angle is given, it will be simply cos theta 1, cos theta 2 because these two angles are complementary angles. These two angles are complementary angles. So, if for this angle, if it is sin theta, for this angle, it will be cos theta. Okay. Now, this formula based question never came in KCET, but this formula based question did came in Comet K. So, you are maybe this year KCET also they can give you a question based on this formula. This is a simple formula, nothing difficult. So, you can remember this formula. So, and this is also this it is there in your NCERT textbook. So, B equals to mu naught I by 4 pi r sin theta 1 plus sin theta 2 if it is a finite wire. Okay, the length of the wire is not infinite. But if you take the same wire, okay, if you take it and make the wire infinite, okay, the wire is infinite, so this line becomes parallel. So, in that case, the theta 1 and theta 2 both becomes 90 degrees. Okay, so if it is an infinite wire, the only way to match that it will be like this. Okay, so the angle becomes 90 degrees. Okay, it's a limiting case. So, the angle becomes 90 degrees. So, sin 90 is 1. Sin theta 2 will also be 90 degrees. This will also be 1. So, 1 plus 1 will be 2. So, 2 will cancel and you will get mu naught by 2 pi I by r. Okay. So, if you remember this mu naught I by 2 pi r, okay, then you can remember this one as well. Okay. So, for infinite long wire, magnetic field is mu naught I by 2 pi r. Now, circular current carrying loop, the previous derivation is not important. Even if they give you this derivation, you can apply Ampere's circuital law. We will show that in a while. Okay, you can find this expression using Ampere's circuital law, but this derivation is very, very important. Okay, here we have a current carrying loop of radius r. Okay, and we are trying to find magnetic field at a distance of x from the center. Okay, so this will be the effective distance, which is given by r, which is equals to square root of r square plus x square. And if you try to find the magnetic field, you will see that the magnetic field is in this direction. So this will be angle phi, this angle will also be angle phi, and only the x component is there. Okay, y component will cancel. Okay, so this is actually the x component of the magnetic field. Y component is 0. So, effective magnetic field due to a circular current carrying loop will be only along the axis of the loop. In any other direction, magnetic field will be 0. So, effective magnetic field due to a current carrying loop will be only along the axis of the loop. And if you find the magnetic field, that will be given by mu naught n I r square by 2x square plus r square to the power 3 by 2. This is a very important derivation. The derivation is very, very important. Okay, you should practice it. If you want me to do, I can do that as well. Anyway, derivation I have done it in my Brahmastra series. So if you want really interested to know how to do the derivation, you can check there as well. Okay, so this is the magnetic field due to a circular current carrying loop. Here capital N is the number of turns. Capital N is the number of turns. So if there are more number of turns than 1, okay, then you have to use this formula. Okay. Now at the center of the loop, this distance x becomes 0. At the center of the loop, this distance x becomes 0. So magnetic field is mu naught Ni by 2r. Okay, so if you put x equals to 0 in this equation, you get the magnetic field at the center. Okay, now for a distance which is very, very far away, loop is there, but you are trying to find the magnetic field at a distance which is far away compared to the radius of the loop. So radius is small, distance is large. In that case, you can ignore this r square and your equation becomes mu naught nir square divided by 2x cube. Now if you multiply pi on both sides, you will get mu naught ni pi r square by 2 pi x cube. Okay, now this pi r square is what? Pi r square is the area of the loop, area of a circle, pi r square. So this pi r square gives the area of the loop. So you can write this as NIA, National Investigative Agency, divided by 2 pi x cube. Now this term, this is a very specific term and that is called dipole moment of a current carrying loop. Okay, M is magnetic dipole moment of a current carrying loop. Okay, so if you substitute that, you will get mu naught m by 2 pi x cube or mu naught by 4 pi 2m by x cube. So now if you remember, in electric field we have studied the magnetic field on the axial plane, electric field on the axial plane is given by 1 by 4 pi epsilon naught 2p by r cube. Remember that this is the electric field on the axis of a dipole. Similarly, this is the magnetic field on the axis of a magnetic dipole. Okay, in case of dipole also we assume that the distance between the dipole is very small compared to the external distance. So if that condition is satisfied, you can consider this current carrying loop like a magnetic dipole. Now what is a magnetic dipole? Very interesting. What is a magnetic dipole? Magnetic dipole is not something which is something new. Magnetic dipole means it's basically a small magnet. So it has a north pole, it has a south pole. This is a magnetic dipole. So current carrying loop basically behaves as a magnet. That is the proof of this. So current carrying loop behaves as a magnet because for a distances greater than r, okay, you get the same expression for magnetic field as you have collected the electric field of a dipole. So this is an electric dipole, this is a magnetic dipole. Magnetic dipole means magnet. Magnetic dipole, the name seems to be fancy, but we all call it a magnet. Okay, but magnet is a term which is used for objects which are made from iron or some alloys, okay, which is a physical thing. You can touch it, you can place it along another iron and it will attract it. This will also attract iron, but this is basically a current carrying loop. If you stop the current, it will lose the magnetic field. That is the only difference between a magnet and a current carrying loop. So current carrying loop behaves as a magnet. Okay, now answer this KCET based question. The magnetic field at the center of a circular coil of radius capital R carrying current I is 64 times the magnetic field at a distance x on its axis from the center of the coil. Then the value of x is, what is the value of x? Answer quickly. So here we have a magnetic field at the center of a coil. Okay, say magnetic field is B, and at a distance x, magnetic field is suppose this is B, then this will be 64B. If this magnetic field is B, this is 64B, then what is the distance? Okay, radius is given here as capital R. Now what formula we'll be using? Magnetic field at the center of the coil, magnetic field at the center of the coil is mu naught by 2 pi I by r. Okay, now here number of turns is anyway same, does not matter, so number of term we are not considering. What about magnetic field at the distance on a point on axis? It is mu naught by 2 pi I r square divided by x square plus r square to the power 3 by 2. Okay, now it is said that BC is actually 64 times BX. This is BX. Okay, now BC is 64 times BX, so you have to put that value over here. So mu naught by 2 pi, not 4 pi, anyway does not matter, even if you write 4 pi it will cancel eventually, it will be equals to 64 into mu naught by 2 pi into this value I r square divided by x square plus r square to the power 3 by 2. Don't forget the power 3 by 2. So mu naught by 2 pi, mu naught by 2 pi cancels, I cancels. Okay, here we have 1. Now cross multiply, you get x square plus r square to the power 3 by 2 equals to, this will multiply over here, you will get r cube. Okay, now if you take cube root on both, there is also 164 over here, so it will be 64 r cube. Okay, 64 was also there. Now if you take cube root on both side, what you will get on this side? You will get x square plus r square to the power half. You are taking cube root. Cube root means cube is gone. What is the cube root of 64? Cube root of 64 is 4. 4 4s are 16, 16 4s are 64, and cube root of r cube is r. Okay, now you take the square of both sides. If you take the square of both sides, you get x square plus r square equals to 16 r square, or x square equals to 16 r square minus r square, that is 15 r square. So x becomes square root of 15 r. Okay, so the distance is square root of 15 r. So correct answer is option D. Correct answer is option D. Yes, Shravan is correct. Shri Short video maker, no, option C is not correct. It is option D which is correct. Okay, don't answer randomly, you have to solve it, at least try at least once. Okay, now KCET PYQs many students tend to remember it because they have solved it many times, but if you are still not able to remember it, try to solve it and check if you are able to solve it or not. Even if you remember the answer, try to check if you are getting the answer if you start from the crash, because in the KCET exam, okay, it does not matter if you remember the answer or not. If you remember the process will be repeated. Questions, exact question will not be repeated, but process, concept, that will be repeated. That is very, very important. Next, identify the correct statement. This is from 2025. A straight current carrying conductor has a circular magnetic field lines around it. The direction of magnetic field due to a current element is given by Fleming's left hand rule. The magnetic field is inside a solenoid is non-uniform. The current carrying conductor produces an electric field around it. Okay, so these are the questions. You have to identify the correct statement. That means one statement is correct, 3 of them are incorrect. Okay, so which one is incorrect? Sorry, which one is correct? 3 are incorrect, 1 is correct. She Short video is saying option A. Gladwin is saying ABD. Okay. So straight current carrying conductor has a circular magnetic field around it. Let's see. So if you have a straight current carrying wire, what is the shape of the magnetic field? I told you at the beginning of the lecture, okay, a straight current carrying wire will always produce circular magnetic field around it. Okay, and current carrying wire generally does not have any excess charge. Okay, the potential difference is there, electrons do drift, but excess charge is not there, so that's why electric field will not be produced by an current carrying wire. Current carrying wire will only produce magnetic field. Okay, single charge moving charge will produce both magnetic and electric field, but a current carrying wire will only produce magnetic field, it will not produce any electric field. Okay, so the correct statement is this one, not D. Okay, some students tend to confuse between A and D. Current carrying conductor does not produce electric field, current carrying conductor only produce magnetic field. Okay, so correct statement is option A. Not do not just randomly answer A, B, D or A, B, C. Okay, you have to answer only the correct answer. Next, which of the following statement is not true regarding Biot-Savart's law? The magnetic field is proportional to the length of the current element. Magnetic field is proportional to the length of the current element. The magnetic field is proportional to the current through the current element. Magnetic field is proportional to the current through the current element. The magnetic field is inversely proportional to the distance of the point. The magnetic field is proportional to the sine of the angle between the current direction and the line joining the current element and the point. So here you have to find the statement which is not true. Which is not true. Gladwin is first, okay, and he says option C. The magnetic field is inversely proportional to the distance of the point. So this is a wrong statement. So what is the correct statement? It is proportional to the square of the distance of the point. So very easy question, but very tricky question. If you just miss it out, if you read it once, you might feel okay, all the options seems correct. So what is the incorrect statement? Because it is said distance of the point, actually correct statement is dB is proportional to 1 by r square. It is not proportional to 1 upon r, it is proportional to 1 by r square. So this is a wrong statement. This statement is wrong. Remaining statements are all correct statement. Next, the value of permittivity of free space is. The value of permittivity of free space is. Easy question, again try it. Dhanush, short videos answered correctly. Dhanush answered, I think you are trying to say question number 9 or question number 8. Dhanush is saying option A. Anyone else? Okay, now Dhanush changed the answer to option C. Short video is also saying option C. Anyone else? So we are talking about permeability of free space. Permeability of free space is mu naught, not epsilon naught. Epsilon naught is called permittivity of free space. Okay, permittivity of free space is this one. Permeability is not. Permeability is mu naught by 4 pi. This is also a very important constant that you have to remember. Mu naught by 4 pi is 10 to the power of minus 7. So mu naught is simply 4 pi into 10 to the power of minus 7. Remember, permeability is for magnet, permittivity is for electric force. Okay, so it will be option A, not option C. Not option C. Very careful. Okay, that's why they have given this question, permeability and permittivity. Now you should have at least one hint that today we are not discussing any static electricity chapter. So the question should be from magnetism, and in magnetism this value is not common, but also unit is also not common. It will be Henry per meter. Unit of permeability is Henry per meter. Okay, now Sri short videos changed his answer. Shravana is correct. Gladwin is also correct. Arvind Hubbali is also correct. Now, Ampere's circuital law. It is similar to that of Gauss's law in electrostatics. Okay, but here we are dealing with magnetic field and current carrying wire. Okay, so that is only difference. In Gauss's law was static charges. Okay, Ampere's law is moving charges. Moving charges, not only moving charges, it is moving current. Okay, the magnetic field around a closed loop depends only on the electric current passing through the loop. Okay, and that is given by B dot dl equals to mu naught I. B dot dl equals to mu naught I. It is similar to that Gauss's law. Gauss's law, we have a surface. In Ampere's law, we have a loop, closed loop. Okay, in that case it was closed surface. In this case we have a closed loop. Okay, surface is a three-dimensional thing, a loop is a two-dimensional thing. Okay, surface is a three-dimensional thing, loop is a two-dimensional thing, line is a one dimension. Okay, now so if you have a closed loop, suppose there is a current carrying wire I1 and some other current carrying wire which is I2. Okay, then if you consider this closed curve, okay, says this closed curve is C, then magnetic field at any point is B. Okay, if you take this integration B dot dl along the curve C, then it will be only B dot dl equals to mu naught I1. I2 will not be considered. I2 will not be considered. Any current which is outside this loop, we will not consider for calculating magnetic field. Okay, now again this law is again valid for all closed loop, or any shape or size does not matter, but remember that if this the closed loop is symmetrical, then it is very easy for us to calculate the integration. That's it. Okay, now I will show you one application of Ampere's law. Okay, that is the magnetic field due to a straight wire. Suppose you have a very straight wire carrying current I. Okay, very long straight wire carrying current I. We want to find the magnetic field, say at a distance P. We want to find the magnetic field at a distance P. So how to do that? We have to construct a Amperian loop, which is a circle, Amperian loop, circular loop, Amperian circular loop of radius equals to R. Okay, in Gauss's theorem we have we say that the loop is Gaussian surface, the surface is Gaussian surface. In Ampere's law it is Amperian loop. It is called Amperian loop. Okay, it's a circle of radius R. Now we are saying that suppose we take a small element dl. Now magnetic field will be constant on this loop because it's a circle of radius R. So each and every point will have are at the same distance. Each and every point are at the same distance. So magnetic field along this line will be constant. Along this curve will be constant. Right? Same as Gauss's law. If you see the application, it is same as Gauss's law. So if you say that magnetic field is constant, so B dot dl along this curve is mu naught I. Okay, this is Ampere's law. Now B is constant. B is constant. It's a dot product. So B and dl, again B and dl are in the same direction. So B dot dl will be B dl. Okay, so B dot dl is basically B dl cos theta. But B and dl are in the same direction, so it will be B dl, and you can write this as B should be outside integration because it's a constant due to symmetry. Constant due to symmetry, nothing else. So due to symmetry, B must be constant and it will be dl. And because they are in the same direction, cos theta is 1. So you get this as mu naught I. What is integration dl? Now if you see that this symbol is called close integration. Close integration. Close integration means when your starting point and ending point are same. If your starting point and ending point are same, then it is called a close integration. Otherwise, definite integration, there is a starting point, there is a separate ending point. Okay, close integration means starting point and ending point are same. So basically if you take small dls and if you keep on adding it, then you get the closed integration dl. So closed integration dl is basically the perimeter of the circle. It is the perimeter of the circle. Closed integration for surface, in case of Gauss's law, it was surface area of the surface. In case of loop or any closed loop, it will be the perimeter of that loop. Here it is a circle, so perimeter of a circle is given by b into 2 pi r. Perimeter of a circle is 2 pi r. Area is pi r square. So it will be mu naught I, or magnetic field due to a straight wire is given by mu naught by 2 pi I divided by r. So you are dividing this on the other side and you are getting b is equal to mu naught I by 2 pi r. Now this derivation is a 3-mark derivation if it is coming in your PU board. Okay, apply Ampere's law to find the magnetic field due to a straight current carrying wire. Now question number 10. Two identical current carrying coaxial loops. Two identical current carrying coaxial loops carry current I in opposite sense. Opposite sense means suppose one of them is carrying a current in this direction, another one is carrying current in the opposite direction. Okay, two identical current carrying coaxial loops. Coaxial means suppose this is a loop, this is another loop. Okay, so this is carrying current in this direction I, this one is carrying current in the opposite direction. Coaxial means their axis is same. Okay, two loops. A simple Amperian loop passes through both of them once, calling the loop as C. So we have an Amperian loop which is passing through them at once, only once. Okay, why once? It can pass, you can construct an Amperian loop which does not pass through them, or it can pass through more than once. That is also possible. So here this loop passes through them only once, and we are calling this loop as C. Okay, we are calling this loop as C. Now it says that B dot dl equals to plus minus mu naught I. The value of B dot dl is independent of the sense of C. There may be a point on C where B and dl are perpendicular. B vanishes everywhere on C. So which answer is correct? Hello Sanjana. Which one of them is correct? Sri Short is saying D, Gladwin is saying C. Dhanush is saying A. Now, let me break it down to you. So here we have two current carrying wires. Now, if the same question was asked like this, that we have two wires carrying current, one is carrying current in this direction, another one is carrying current in the opposite direction, and you have a loop. Okay, say C. Now what would be the answer? So the current is I, this current is also I. So integration B dot dl equals to mu naught I minus I. Okay, so I in this direction is, if you take this as positive, this current will be negative current. So that means B dot dl is equals to 0. Okay, now dl cannot be 0. dl has a fixed value. If you take closed integral, you will get the perimeter. So dl cannot be 0. So on your right hand side, if you have 0, then your left hand side will also have to be 0. dl cannot be 0. So that means magnetic field B has to be 0. Okay, so if this is the case, B is 0. Now if you consider this one, now here also if you see this loop is basically covering both currents only once. So both current is being crossed only once. That means it is basically the same situation as this. This one is same situation as this. So in this case also, basically, if you consider this current positive, this current will be negative. So the net current passing through the loop is 0. Net current passing through the loop is 0. So each and every point along this curve C, B is 0, that is B vanishes everywhere on C. B vanishes everywhere on C. So this is the answer. Not A, not C, not B. Okay, B is 0, that means B vanishes everywhere on C. Very interesting but simple question, but you should be able to understand the concept. If you understand the concept, you should be able to answer this as well. Let's move on to our next topic, which is solenoid. Solenoid is also super important. What is a solenoid? Solenoid structure we know. If you take a wire, if you take a cylinder, if you wind the wire on the cylinder, then the structure or the design that you get is called a solenoid. It has an entry point, it has an exit point. Okay, so solenoid is one example of solenoid is the solenoid like structure is your rheostat. Okay, rheostat, even though it is a solenoidal structure, even though we do not use rheostat for solenoid purpose, we use it for resistance purpose. Okay, but that is one good example of solenoid. Okay, but solenoids are everywhere. Okay, solenoids are one of the most used part in our day-to-day life. Okay, solenoids are there in the, if you are listening to me using an earphone or a microphone, even in fact for microphone of your mobile phone, okay, they all have solenoid installed in it. The bigger the solenoid, more sound it can produce. Okay, in fact, if you watch the large volume boxes which vibrate with the sound, its vibration is actually vibration of the solenoid. Okay, solenoid behaves as a magnet, so the sound coil has a permanent magnet and a solenoid. The solenoid's magnetism changes with the volume. Okay, so if I am talking a little louder or based on frequency as well. Okay, so based on that, the current passing through the solenoid changes and the solenoid starts vibrating, and based on that vibration, sound is produced. Okay, solenoid is one of the most used element in our day-to-day life, especially all the sound-based elements, they have a solenoid installed inside it. Tiny, it can be large, it can be sensitive, it can be more based on requirement, you can adjust your solenoid. Now, solenoid produces a magnetic field. Main part is solenoid produces a magnetic field when you allow a current to pass through it. Okay, and magnetic field inside the solenoid is constant, and that constant is given by mu naught n into I. So magnetic field inside the solenoid depends only on the current I. It does not depend how long the solenoid is or how closely the solenoid is wounded. Okay, it only depends on mu naught n and I. What is n? N is the number of turns per unit length. Number of turns per unit length. It is not dependent on length. The magnetic field of a solenoid is not dependent on length. Okay, but yes, length do matter in another cases, some cases. Okay, if you want a very good clarity, okay, so length can be important, but for magnetic field purposes, length is not important. Okay, so if you know the total number of turns, if you know the length of the solenoid, then number of turns per unit length is given by this. Okay, this is, you can say, the line density of windings. Okay, so this is the structure. Let's move on. Force between two parallel current carrying wires. Force between two parallel current carrying wires. Now, suppose we have two wires carrying current. Okay, or in other case, one wire is carrying current in this direction, another wire is carrying current in the opposite direction. Both is possible. Okay, now if you consider a current carrying wire, we know that a current carrying wire produces a magnetic field. Okay, a current carrying wire produces a magnetic field. We have used Ampere's law to find that magnetic field. And also, if you keep a current carrying wire in an external magnetic field, it experiences a force BIL sin theta. Okay, so if you see that here, if you consider the first wire, it will produce a magnetic field. This magnetic field will not affect this wire itself. Okay, obviously the magnetic field produced by the own wire will not affect it, but it will affect any other wire present nearby. So this wire will apply a force on this wire, okay, and this wire will apply a force on this wire as well. Okay, so these two wires will apply force on each other, and that is called force between two parallel current carrying wires. The force between two parallel current carrying wires is given by mu naught Ia Ib by 2 pi r into L. Very easy derivation. So if you say that the current through this is Ia, current through this one is Ib, okay, then the force between these two, now remember, if the currents are in the same direction, they will attract each other. If current are in the opposite direction, they will repel each other. Opposite currents repel, same current attract. Okay, now F12, suppose this is F12, then this will be F21, and in any cases these two forces will be opposite to each other. So they are trying to move towards each other, so this is a attraction force. In this case they are trying to move away from each other, so this is a repulsive force. Okay, force per unit length. For force per unit length, you have to put L equals to 1 in this expression. That's it. Okay, and you can calculate the force per unit length. In exam, they will ask you to calculate force per unit length, which is given by mu naught by 2 pi I1 I2 by R or D. Okay, we use this symbol in your PU board exam. So this derivation is important for PU exam, and sometimes they might ask you define 1 ampere from this. How to define 1 ampere? Some students do not know it. So to define 1 ampere, what you have to do? You have to take I1. If I1 equals to I2 equals to 1 ampere, distance between the wire is 1 meter. Okay, then the force per unit length becomes mu naught by 2 pi, that is 2 into 10 to the power of minus 7 Newton per meter. Why Newton per meter? Because it is force per unit length. Okay, so you have to define 1 ampere such that if 1 ampere, two current carrying wires carry 1 ampere current in the same direction kept at a distance of 1 meter, then they will experience a attractive force of 2 into 10 to the power of minus 7. That is the magnetic definition of ampere. Okay, from magnetic field you can define ampere, which is very, very interesting. Now, torque on a rectangular current carrying loop. So this is also important. So if you have a current carrying loop, the current carrying loop will produce its own magnetic field, right? We have seen that. Now again, if you place that same loop inside a external magnetic field, here we have taken a north pole and a south pole, and if you apply, there will be a magnetic field, and because of this magnetic field, this loop will experience a torque same as dipole kept in an external electric field. Okay, here it is a magnetic dipole, here it is a magnetic field. Because of this external magnetic field, the dipole will experience a torque. Now the torque can be calculated as torque equals to IAB. Okay, if there is only one loop is there, it will be IAB. Okay, and this torque in vector form can be written as I into A cross B. Area is a vector quantity and magnetic field is obviously a vector quantity, so it will experience as a torque, and because of this torque it will start to rotate. The magnetic moment of a single loop is defined as magnetic field equals to I into A. For n number of turns it is given by NIA, so the torque becomes, the general formula for torque becomes M into B, or scalar wise torque becomes NIAB, Nayab. Those who know this term, this is a Urdu word called Nayab. Nayab means precious. Okay, you can remember it like this. Nayab. Okay, torque is NIAB. Okay, N is number of turns, I is current, A is area, B is magnetic field. Okay. Now, moving coil galvanometer, we have all used it in our laboratory, and some of you are going to use it in your laboratory in upcoming practical exams. Some of you may have already given practical exams and they actually faced this experiment, okay, where you have to find the figure of merit of a galvanometer. Okay, anyway, so when you apply a current, so what is the working principle of a galvanometer? Working principle of a galvanometer is this. Okay, a current carrying loop is there inside a magnetic field, and based on the value of the current, the loop rotates and you get a deflection. Now in this case, this is not allowed to rotate freely, so there is a spring involved over here. That spring controls the rotation. Now based on the torque that is applied on this loop, the spring balances the motion. Okay, and it deflects by certain amount. If the torque is very high, it rotates by a large amount. If the torque is small, then it rotates by only a small amount. So depending upon the current, there is a torque, and depending upon the torque, it rotates by an angle. Okay, so the rotation or the angular rotation of a moving coil galvanometer is represented by phi. These are very basic fundamental concepts. Many students actually don't know how a galvanometer works. They have seen that kind of box, they allow some current and it deflects. Okay, so basically the inside the galvanometer, if you open the galvanometer, you will find two magnets, you will find a coil and a spring. That is basically it, and a needle fixed with that, and a scale according to the measurement. Okay, now the deflection of the galvanometer, the angular deflection of the galvanometer is proportional to the current which is passing through the galvanometer, and here this is called galvanometer constant. This G is called galvanometer constant. For a particular galvanometer, this is a constant. Okay, now phi equals to angle of deflection, and galvanometer constant is given by NAB by K. N is number of turns in the loop, A is the area of one loop, B is the magnetic field due to the magnets, and K is the spring constant. Okay, N is total number of turns, okay, A is area, B is magnetic field, and K is spring constant. Okay. Now this same galvanometer can be converted into two more useful parts, which is, okay, Bina is also fine. Shorts video, Bina is also very good. Okay, you can remember Bina is a instrument. So if you are a musician or if you have music, Bina is a stringed instrument having four basic strings. Okay, produces some sounds. Okay, I am not a musician, so I don't know, but I know that Bina has four strings. Anyway, galvanometer to ammeter. The ideal ammeter should have, now you can convert a galvanometer either into an ammeter or a voltmeter. Galvanometer, what is the purpose of a galvanometer? Purpose of the galvanometer is if there is a charge moving in a circuit or not. Okay, so if there is a charge moving, galvanometer can detect. It cannot measure how much current or how much voltage is there. Okay, so galvanometer is only there to detect. It cannot measure. That is the drawback of galvanometer. Okay, to measure current or voltage, you have to convert the galvanometer. Okay, galvanometer can be converted into ammeter or voltmeter. Now, what is the role of ammeter? Ammeter is a device that measures current. To measure current, what you have to do? You have to connect the ammeter in a series circuit. Okay, suppose there is a resistance. Resistance is carrying some current. How can you measure that current? To measure the current, you have to add an ammeter in the series circuit so that it can measure the same current passing through it. Now, if the ammeter itself has a very high resistance, then the overall balance of the circuit will be disturbed. Okay, because if you are adding something in series, we know that if you are adding something in series, what happens? The total resistance of the circuit increases because they are algebraically added, right? So if ammeter itself has a very high resistance, then the overall balance of the circuit will be disturbed. And in that case, suppose you want to measure the current, you are getting a very low current. You think, okay, this current may be safe for the circuit, but actually the original current is very high. You are measuring something wrong because of the faulty ammeter. So ammeter should be a device, ideally it should have a zero resistance. Ideal resistance of an ammeter should be zero, but in practicality zero resistance is impossible, so we try to keep the resistance of ammeter as low as possible. Okay, so an ideal ammeter should have a zero resistance. In practical, ammeter's resistance is kept as low as possible. Now how can you keep resistance of something low? For that we apply parallel combination logic. If we add a parallel resistance of very small value, the equivalent resistance of the circuit becomes smaller than the smallest one. Okay, that is a property of parallel combination of resistances. Okay, if you connect two resistances in parallel, the equivalent resistance becomes smaller than the smallest. So for example, if you add say 1 and 2 in parallel, okay, the equivalent resistance will be in fraction, it will be smaller than 1. Okay, so that's why we connect a shunt, a small value resistance in parallel is called a shunt. Shunt is a specific term when a small value resistance is connected in parallel, okay, which allows to pass the extra current through it. Okay, shunt means a way to allow extra current to pass through it, okay, in parallel to the galvanometer. Okay, so that's how we convert a galvanometer into ammeter. So this part is there. If the question is asked in your PUC exam, then you should remember it. Otherwise, the current sensitivity. So this is a current measuring device. Okay, this is a current measuring device. So how much sensitive it should be to current? Okay, sensitivity means even a small change of current should be able, the galvanometer should be able to detect even a small amount of change in current. Okay, so this is called sensitivity. Some of the galvanometer, some of the ammeter can detect only when the change is large, then only it changes. Otherwise, small changes, it still stays there, okay, without any changes. So only a large amount of current change can be detected by normal ammeters, but if it is a very highly sensitive, it can detect even a small amount of change. Now what is the sensitivity? Sensitivity is given by the angle of deflection divided by current. Okay, angle of deflection divided by current, and current sensitivity is given by NAB by K. Current sensitivity is NAB by K. This is also sometimes called current sensitivity or SI. Okay, current sensitivity. Higher the sensitivity, small change can be detected. Okay, but it has also some drawbacks. Sensitivity and stability are opposite. Sensitivity as something which is more stable can be low sensitivity. Something which is more sensitive can have a low stability. Okay, stability and sensitivity are opposite to each other. Now current sensitivity can be increased by increasing the number of turns. So if you increase the number of turns present inside the galvanometer, you can increase its sensitivity. The current that is being measured by the galvanometer, the ammeter, is given by this formula. This formula is used to measure the current. This current, you are measuring this current, not Ig, not I minus Ig. Ig is the current which is passing through the galvanometer. Okay, so this is basically maximum current it can measure. If you know the maximum current that is allowed through the galvanometer, you can find the maximum current an ammeter can be measured. So this is a conversion related questions where they will give you a galvanometer is converted into 5 ampere, a galvanometer which can have only 0.1 ampere current, maximum current is converted into a 5 ampere ammeter. what should be the shunt resistance. So based on this formula you can calculate it. Okay, so if you remember this formula it's fine, otherwise you have to remember in parallel combination voltage drop is same. So Ig minus I minus Ig into S equals to Ig into G. That is also fine. At least one of the concept you have to remember. Next is voltmeter. Now voltmeter is a device which is used to measure voltage. How can you measure voltage? Again the same case, a resistance, you want to measure the voltage. So to measure the voltage, voltage is basically we say across, right? Voltage is measured across. So you have to connect the voltmeter parallel to the resistance. Voltmeter has to be connected parallel to the resistance. Now this voltmeter originally, if it has a very low resistance, then these two will be in parallel combination. So current will pass more through the voltmeter than the resistance. So you will get again a wrong measurement. Okay. So ideal voltmeter should have a infinite resistance. Resistance of an ideal voltmeter should be infinite. Ideal ammeter is 0, ideal voltmeter should be infinite, so that it does not disturb the balance of the circuit. Main part is that any device, when you are adding it into a circuit, it should not change the balance of the circuit. Here, because voltmeter is a device which measures the voltage, it should not change the balance of the circuit, and that's why it is connected. How to convert it? To convert a galvanometer, we have to connect a high value resistance in series to increase the resistance of the voltmeter. To increase the resistance of the voltmeter, we have to connect a high value resistance in series to convert it into a voltmeter. Now voltage sensitivity is again phi by V, which is given by NAB divided by R into K. Okay, R is the resistance. Okay, NAB R into K, this is the resistance of the coil. Now voltage sensitivity cannot be increased by increasing the number of turns. Why so? If you increase the number of turns, then the resistance of the coil will also increase proportionally, because resistance is proportional to length. Suppose you have a 10 round coil. Now if you say, okay, I will increase it to 100 turns, will my sensitivity increase? The sensitivity, current sensitivity will increase, but voltage sensitivity will not increase. Okay, voltage sensitivity will not increase because there is a resistance involved, and if you increase the length, the resistance will proportionally increase, and that's why only increasing the number of turns is not sufficient in case of voltage sensitivity. Okay, and the voltage that you are measuring in a voltmeter is given by this formula. Voltage that you are measuring in a voltmeter is given by this formula. V equals to Ig into G plus R. Okay, G is the galvanometer resistance, R is the resistance that you have connected in series. Okay, now question number 11. The number of turns in a coil of galvanometer is tripled. Then both, so just whatever I have concluded in the last concept, that same concept based question is here. The number of turns in a coil of galvanometer is tripled. Then both voltage and current sensitivity remains constant. Voltage sensitivity increases 3 times and current sensitivity remains constant. Both voltage and current sensitivity decreases by 33%. Voltage sensitivity remains constant and current sensitivity increases by 3 times. So what is the answer for this? By the way, we are almost at the end of our lecture. I will try to conclude it in next 4 to 5 minutes. What is the answer for this question? The number of turns in a coil of galvanometer is tripled. Then which sensitivity will be changed? So what is current sensitivity? Current sensitivity is NAB by K. Okay, so if you increase the number of turns, if you change the number of turns to 3 times, current sensitivity will also be 3 times. If you change N to 3N, current sensitivity is directly proportional to number of turns, so it will increase. What about voltage sensitivity? Voltage sensitivity is NAB by RK. Okay, so N by R is constant. N by R is constant. So even if you increase the number of turns, N by R will remain constant. It will not change. So voltage sensitivity would remain constant. Okay. So yes, option D is correct. Gladwin is correct. Voltage sensitivity will remain constant and current sensitivity increases 3 times. A solenoid is 1 meter long. A solenoid is 1 meter long and 4 centimeter in diameter. Okay. So length is given, diameter is given. It has 5 layers of windings of 1000 turns each and carries a current 7 ampere. The magnetic field at the center of the solenoid. So let us understand the question first. Here we have a solenoid. Here we have a solenoid. Okay, solenoid has, okay, the solenoid has number of turns, total number of turns. Now it has 5 layers. 5 layers means this is 1 layer. So once this layer is done, there is one more layer on top of it. Then we have one more layer on top of it. Like that we have 5 layers. Total number of layer is 5. And each layer consists of 1000 turns. Each layer consists of 1000 turns. The length is 1 meter. Okay, the length is 1 meter. Diameter is not important over here. For a solenoid, the magnetic field is given by mu naught Ni. Okay, mu naught Ni. Now N is number of turns per unit length. Number of turns per unit length. Now here 1000 turn is there, but we have 5 layers. So total number of turns is 5 into 1000. Okay, that is 5000. Now what about small n? Small n is simple. Capital N divided by length. Length here is 1 meter. So length here is 1 meter. So it will be again 5000. Small n is also 5000. Be careful, in some cases they will give you half meter or 2 meter. So in that case it will not be exactly same as capital N. Now mu naught is 4 pi into 10 to the power of minus 7. Number of turns is 5000 and I is 7 ampere. So just use this formula and calculate the magnetic field. Now you are not allowed to use calculators, so you have to solve it in hand. So 5 into 7 is 35. 35 into 4 into 3.14 into 10 to the power of minus 4. Okay, so these 1, 2, 3 zeros I have adjusted across this 10 to the power of minus 7, and then what we have done, we have just taken 5 sevens are 35, 4 is here, and pi is 3.14. Just simply multiply. Okay, so it will be 120, 120, 140 into, or let me write it as 22 by 7. That will be easier. Okay, pi 22 by 7 is easier because I can cancel. It will be 20. Okay, so 20 is 440 into 10 to the power of minus 4, or 4.4 into 10 to the power of minus 2. Okay, so answer is 4.4 into 10 to the power of minus 2. So if you see all the options, you will get correct answer is option A. If you had used 3.1414, you would have got this exact 4.396, but our approximation with 22 by 7 is very good, and we have got 4.4 into 10 to the power of minus 2. Only one answer is closest, that is 4.314. Shorts video is saying A. Shravan 2A. Why you are answering question number 2? It is question okay, sorry, it is question number 12, not 2. Okay, my mistake. Yes, A is correct. Right, let's move on. in a moving coil galvanometer, the deflection phi on the scale by a pointer attached to the spring is given by. So in a moving coil galvanometer, what is the value of the deflection, which is Gi? Okay, if you remember the value of G, then you can answer it. I just told you shorts video, I think he even suggested a something name for it. Okay, now answer this question. What is the answer? A moving coil galvanometer, in the deflection phi, the scale of the pointer attached to the spring is. Trupti Nataraju is saying option C. Yes. So NABI by K. Okay, so G is NAB by K. So remember, you have to multiply current with it. So that's how you get the deflection. Okay, so NAB by K into I. So this is the deflection attached to the spring. Question number 14. An ammeter and a milliammeter are converted from identical galvanometer. Which one has smaller resistance? Ammeter, milliammeter, both have equal resistance. The resistance of an ammeter may be more than or equal to that of milliammeter depending upon the range. Okay, so what is the question? What is the answer? Milliammeter and ammeter both are converted from a same galvanometer. That means internal resistance of the galvanometer is same. Now an ammeter is measuring in the range of Ampere, and milliammeter measures in the range of milliamperes. Okay, that is the only difference. Okay, now you can use this concept that current measured current is given by Ig into G plus S divided by S. Okay, this concept you can use. Now for this particular case, Ig is constant, G is constant. What resistance you have to connect in the shunt? Which one will have? Okay, they are not asking about shunt, by the way. They are not asking about shunt, they are asking about the total resistance. Which of the galvanometer has smaller resistance, total resistance? Okay, which has a smaller resistance, not the resistance in parallel. Okay, shunt resistance they are not asking, they are asking the total resistance. So if this is G, this is S, what is the total resistance? Total resistance is GS by G plus S. Okay, this is the total resistance of the galvanometer, ammeter. Okay, ammeter or milliammeter. Which one has a smaller resistance? Ammeter, milliammeter, both have equal resistance. Resistance depends on the range. Sir, I am not able to join the WhatsApp group. Is there any other way to join the WhatsApp group? Study for fun. It is easy. You can visit either from this video, or you can go to any one of our old video. WhatsApp joining link is there. Okay, you have to use the phone where WhatsApp is installed. Okay, if you are using a phone where WhatsApp is installed, you can easily join the WhatsApp channel. Once you are going there, you have to click on the follow button. Okay, so once you are into the page, there is an option called follow. If you click on the follow button, it will be there. Otherwise, if you want, I will try to share the link of our WhatsApp channel at the end of this video. Once this video is over, okay, try to check it after 1 or 2 hours. I will try to share the link of our WhatsApp channel in the once the video is over. Okay, because sometimes it takes some longer time to close the live session, because even if I end it here, if it is not closed from the admin end, the video still continues. So admin sometimes may take some longer time to close the video. So once the video is closed, the chat section of this video is open. So I will paste the link over there as well. Okay, you can join from there. Okay, the PDF of this lecture and all the other lectures that were already there will be shared on our WhatsApp channel. We have shared the schedule of master stroke series as well. So you can join our WhatsApp channel and check the schedule. You can download the PDFs. I will ask our admin to share the links once more. Okay. Sir, is 1 month KCET preparation enough for second PUC? I am not sure. 1 month KCET preparation enough for one PUC? No. So if you are starting now, you have 3 months. Okay. In between, you have around 1 month's time for your PUC board exam. Okay. So you have to prepare at least 2 months. If you are only preparing for 1 month, if you have prepared in the past, fine. But otherwise, once your board exams are over, you can expect your rank basically decreases. Okay. So right now, if you start right now, you can get a rank say around 2,000, 3,000, under 5,000. But if you start after your board exam, that is you are saying 1 month preparation, okay, your rank will be after 50,000. Okay, your rank will increase by a lot. You will get a rank around 25 to 50,000. It will not be around below 5K or below 10K will not be possible. If you start today, even 1K is possible if you are serious enough. Okay, if you are not serious enough, okay, if you are doing it casually, still 5K, 10K is possible. But if you are starting say after your exam, some students at least 10K to 20K students are already ahead of you. So you will get a rank after them, okay, and based on that exam day preparation participation, the rank decreases further, okay. So you will get a rank, obviously you will get a rank 20K, 30K, but it will not be a very good rank. If you start today, you are still able to score a rank below 5K, which is easily gettable. Otherwise, if you start after your PU exam, the rank will decrease. That is the only thing going to happen. Now, so ammeter and milliammeter. Ammeter means what? Ammeter means more current passes through the galvanometer, and galvanometer current is constant, so more current passes through the shunt. Okay, I minus Ig, so more current passes through the shunt. Shunt has a smaller resistance, so for an ammeter, the resistance of the shunt is much smaller compared to milliammeter. Okay, milliammeter, only a small amount of current is passing through the shunt. Okay, so overall resistance wise also, the resistance of ammeter is much smaller compared to a milliammeter. Okay, so resistance of a ammeter is much smaller compared to a milliammeter, so option A is correct. Okay, shorts videos answered it. I see. Okay, please help like how to start from today, like from which second PUC to first PUC, and how much questions daily. So Anand Prabhu, what you can do is that you can start with our master stroke series. Our master stroke series is something which is designed about 80% of KCET and 20% of PUC. Okay, so if you start with our master stroke series, we are currently doing second PUC chapters, and we will be covering all the second PUC chapter without any break. All the second PUC chapters will be done there. So you can check physics, chemistry, maths, and biology if you want. If you are appearing for biosciences as well. Otherwise, if you are only preparing for engineering, then physics, chemistry, maths, master stroke is a must watch. Okay, so that is the first thing. Second thing, how many questions you have to practice? You can solve previous year questions from PYQ book. Okay, we also have ABHYAS test series. If you want to purchase ABHYAS test series, it is available for 1499. That also you can do it. There you will get the only relevant previous year questions as a quiz format. You can solve there also. Also you will get a standard KCET level paper. You can practice from there as well. Okay, that is your choice. I am not obviously forcing you. You can do that. But anyway, you have to remember that time is very important, so you have to utilize your time. So if you are studying for say why I am saying master stroke is a very concise way of teaching, where we are teaching 1 hour to 1.5 hours. So within 1.5 hours all the lecture is over. So if you want to study physics say 1.5 hours, okay, if you watch that video, your entire chapter will be done. Your entire chapter will be done in that 1.5 hours. Then you can practice 1 hour more. Okay, previous year questions. If you have a PYQ book, okay, do not purchase any other book, because right now there is not much time. You can practice again after your board exams are over, but right now you should not practice too many new questions. Right now you should focus more on your chapter completion and previous year question practice. Okay, so 2 hours, 2.5 hours per day you should allocate for KCET. Remaining time you should allocate for your PU2 preparation. Okay, that's how you should continue. Okay, 2 to 3 hours per day is minimum right now to get a good rank in your KCET exam. Okay, and that is that's why we have started our master stroke right now. Okay, we could have started after your board exams are over, because many students have not started their preparation, so we decided, okay, let them help. Okay, they can study their PUC as well. There also we are talking about how it can helpful for PUC. Again, PUC detailed PUC is not there, only the conceptual PUC is there. Conceptual PUC is also helpful for KCET, right? So we are telling you that this concept is coming for PUC, this question will come, how to write the answer, etc. we are discussing. Okay, so that will be helpful for your PUC as well as your KCET preparation. So master stroke series is one of our most beloved series from last year. Last year we had more than 20K in one of my video, 26K I got in one of master stroke videos. Okay, so master stroke is already started from this Monday or Tuesday. It is lectures coming from Tuesday, so you should check that video. Not many videos are done so far. Every day 2 videos are coming, one day physics and chemistry, one day mathematics and biology. Okay, chemistry ma'am is not well recently, that's why chemistry videos, some of the chemistry videos are not gone live, but we tried to give as much as possible. Okay, and if you have any comments, any doubts, any clarification, you can mention in that particular video's comment also. Yes, master stroke along with question practice is enough. Okay, theory wise master stroke is obviously relevant, but if you want to practice questions, if you practice questions along with master stroke, that should be enough. Okay, and for practicing question you can follow any reference book, or you can follow our ABHYAS KCET test series, which is very good test series, where you will get 35 tests. Okay, each paper consists of 60 questions, so you will get enough practice material. But if you are starting today, I will request you purchase ABHYAS after your board exams. Okay, because right now you should focus more on concepts and PYQs. Then you can purchase ABHYAS after your board exams, and then you can practice from there. Okay, that is a very good case, because what we have realized, why we launched ABHYAS, because what we realized is that books that is available on market, they are giving you too much questions. Okay, too much questions are there for each and every chapter, and many of those questions are not relevant for KCET. People start panicking after seeing those many questions. So you don't need to practice too much, you need to practice precise. That is important. Okay, too much is not helpful, precise is helpful. If you want to practice too much, you can do that, but that you can do if you started, say, at first PU only. You are very serious student, like a topper starts at first PU. Some of them start at class 10th as only. Okay, and they get top rank. But obviously I am not asking you to get the top rank, but you can get a good rank if you, even without starting back in class 10th or class 11th, you can still get a good rank if you start today. Okay, for that you don't need to practice too much, you have to practice precise. Right, now here is the formula sheet for the chapter. Once you download the PDF of this lecture, you will get this formula sheet as well. All the formulas are listed over here. Okay, including galvanometer, torque on a rectangular loop. Every formula is listed. Also, I have 5 practice questions. You should practice these 5 questions. These are not KCET PYQs, by the way. You should practice these questions for your KCET preparation. KCET level practice question, 5 questions I am giving. You download the PDF. How to download the PDF? Join our WhatsApp channel. Okay, the link of the WhatsApp channel is given in description of this video. Also, all the videos have description of our WhatsApp channel and ABHYAS test series as well, so you can follow from there as well. So this is the practice question, question number 3, question number 4. You can pause the video, you can answer it right now as well, and mention the answer in the comment section of this video. Okay, this is question number 4. I am not going to give you the answer. This is practice question. That is the main part of the practice question. You have to solve it yourself, right? So try to solve it and see if you are able to solve it or not. Okay, don't take help from internet, that will not be beneficial for you. If you solve it on your own, after solving it you can check the answer in internet, otherwise do not take help from internet, solve it yourself first, which is very, very important. Okay, this is question number 5. When a charged particle moving in a velocity is subject to a magnetic field B, the force on it is 0. This implies what is the correct option. Okay. So this is the end of today's lecture, and if you have any questions, any comments, any suggestions, don't forget to mention in the comment section of this video. And let me take few comments from Anant Prabhu. Sir, should we complete NCERT of Physics KCET like last 2 months left, right? So NCERT, you do not have the time to complete the entire NCERT right now. NCERT is a 1-year course. So the course is designed for 1 whole year. How can you complete that in 2 months? And it is not only about physics. You have to complete physics, you have to complete chemistry, you have to complete maths as well. Okay, so if you had started say at least 6 months back, I could have said okay, NCERT is sufficient. But you don't have the time to complete NCERT right now. If you start with NCERT, you will be lost. If you have at least completed NCERT once before, you can revise NCERT and recomplete it once more, because recompletion does not take much time. Okay, and KCET, even though question comes from NCERT, all the question comes from NCERT, but not entire NCERT is important. Okay, there are some specific areas from where questions comes. Okay, that's why the entire NCERT extract is masterstroke. Masterstroke is basically we are not teaching anything new. We are not teaching which is completely different. We are extracting NCERT which is relevant for KCET, which is relevant for your PU, and we are teaching that in our masterstroke. Okay, masterstroke you can say NCERT extract. Okay, so you don't need to study NCERT. NCERT is a big book. You have volume 1, you have volume 2 for each subject, which will take a long time if you start today. Okay, so more important is to finish the syllabus. All the chapters, you cannot even leave out one single chapter. Okay, except electromagnetic waves. That is only one question comes from the chapter, and that most question is easy as well. Kumuda is saying, sir, is KCET is about more conceptual based or formula based? Kumuda, it is more, mostly it is concept based. Formulas are also there, but formulas are direct. Okay, so suppose if I say that what is the force between two charges, I am giving you one example. What is the force between two charges? Okay, in JEE, if you attempt JEE or NEET, they will not ask you what is the force between two charges. What they will say that one charge is kept in moon, another charge is kept in earth, the medium between them is filled with water, half of them is filled with water, half of them is filled with sand. Sand has a dielectric constant 4, water has a dielectric constant 2. What will be the force between them? So here you have to apply multiple concepts to figure out the answer. In KCET, out of 60 questions, okay, 40 questions will direct answer based. Direct answer based means either you get a concept based question, you know the concept, you can answer it directly, or you apply a simple state formula, put the values, calculate the answer. It will not be complicated. One formula, you calculate using one formula, then take the value to put another formula, then calculate. Okay, that is not going to happen. In KCET, major portion of the questions, that is 40 out of 60 questions, will be direct formula based. Okay, 20 questions will be there. Out of the 20 questions, there will be some experiment based questions. Okay, some questions where you have to, even if they are direct questions, you have to apply multiple theories to find out the answer, and in some cases you have to apply multiple formulas to find out the answer. Okay, so even if they are formula based, they will be direct formula based. You don't need to use multiple formulas to calculate the answer. That is the main essence of KCET. Okay, what is the Khailan? Sir, I know the derivations, 2 mark questions and 3 mark questions very well. I am thinking of starting previous year questions from now. However, I am not very good at numerical problems. So, Khailan, what you have to do? You have to start numerical questions. We all are weak. Okay, if some difficult question comes, we all will not be able to solve it. So one thing you have to do, what you have to do, you have to dedicate some time every day or at least once in 2-3 days. Okay, during that time you have to pick up at least what you have to solve, NCERT numerical questions, NCERT textbook numerical questions. Those questions you have to read, try to answer those questions. If you practice those questions at least twice, if you practice those questions at least twice, your overall level of confidence in numerical will be many times. Also, you remember, you only need to answer 2 numerical questions, and I recommend only 4 chapters from where you have to practice numerical questions. You do not need to practice numericals of all the 14 chapters. Electric charges and field, okay, electric charges and field, electrostatic potential and capacitance. Out of these 2 chapters, you are going to get 1 numerical. Next is alternating current, formula based, simple calculator based problems, you can solve them. Okay, so these are the 3 chapters. 4th one you can choose either between current electricity or ray optics. These 4 chapters you have to practice numericals from. Okay, electric charges and field, electrostatic potential and capacitance, alternating current. Now this 3 chapter is sufficient to answer 2 questions, but if one of the question is slightly tricky or difficult, then you need a backup. Okay, that's why I recommend either ray optics or electric charges, electric current. Okay, electric current, if you are comfortable with solving circuit diagram based questions, then electric current. If you are not, then ray optics. Okay, many students skip current electricity because they are not super confident with numerical questions of that chapter. Okay, I have done one live in the past where I was discussing all the questions from the current electricity chapter. You can go and check that out. It was called circuit theory live, where I have discussed all circuit related questions including current electricity questions. Okay, question bank, MCQs and numericals enough for boards. Anand Prabhu, question bank 2026 MCQs and numericals are more than enough. If you get time, practice all the questions. They have a lot more questions. Okay, you don't need to practice all the MCQs. All the MCQs you should practice all. Numerical questions, if you practice from the 4 chapters I suggested, that is sufficient. Okay, and the question level of the model paper is slightly higher. Some of the questions are slightly higher. Board questions are generally slightly easier. So if you practice model paper also, it is well and good, right? Model paper is also one good way from where you can practice numerical questions. But I will recommend, if you are starting with numericals or if you are very weak in numericals, you should start with NCERT numericals. Okay, in KCET exams, in PUC board exam, there are many instances where the exact question from NCERT is given. Okay, and in some cases, if the question is difficult, the difficult question is from NCERT textbook. There are some easy questions in NCERT, some difficult questions in NCERT. Okay, so difficult questions from NCERT is given in your board exam. So you should practice your NCERT first. If NCERT is done, then you can practice from question bank. But first, you should practice from NCERT textbook numerical questions, right? Okay, Anand Prabhu with okay, Mashkilan, Masha Kali Khan, nice name, Masha Kali Khan, I think. Right? Okay, thank you everyone. I'll be back with more lives very soon. Master stroke lives are starting from tomorrow. Okay, from tomorrow onwards, Master Stroke live is starting. So if you want to join Master Stroke live, where we are solving live new questions from KCET, previous year questions, so you can join us. You can ask your doubts. Okay, whatever questions you have. Okay, and obviously we will be merging 2-3 chapters. So we are not going to do all the previous year questions. Only the important numerical questions we will be discussing tomorrow. I think either Jasmine ma'am's live is there. Tomorrow is Jasmine ma'am's live is there, and Sunday is Ankit sir live. I'll be back with live on Monday with Master Stroke, right? Till then, bye. See you soon.